Routers. Think of a router as the air traffic controller of the digital world, while a switch connects devices together to form a local network. The router is the specialized host that connects those networks to each other. It is the gateway that allows data to leave your home or office and find its way across the vast ocean of the internet. To truly master the router, you must understand the Layer 3 logic it uses to make decisions, the difference between a home appliance and an enterprise beast, and the critical role of the routing table. The intelligence of Layer 3. In the OSI model, routers operate at Layer 3, the network layer. Unlike a switch, which looks at physical MAC addresses, a router only cares about IP addresses. When a packet of data arrives at a router, the router performs a process called de-encapsulation. It strips away the outer layer to look at the destination IP address. It then consults its brain, the routing table, to find the best possible path to that destination, if the destination is not on the local network. The router forwards the packet to the next router in the chain. This process repeats, hop by hop, until the data reaches its final destination, halfway around the world. The core features, NAT and DHCP. In your work with home and small business networks, you will find that a router is rarely just a router. It usually performs several critical subroles at the same time. The most important of these is NAT, or Network Address Translation. Your internet provider only gives you one single, public IP address. However, you might have 50 different devices in your building that all need to use the internet. The router uses NAT to act as a translator. It gives every internal device a private, hidden IP address, and then manages the traffic so they can all share that one single public connection simultaneously. Additionally, as we discussed previously, most routers also act as the DHCP server. They are the hosts that automatically assign those private IP addresses to your laptops, phones, and printers the moment they plug in. Home routers versus enterprise routers. It is a common mistake to think that the Wi-Fi box in your living room is the same as a professional router. They serve the same logical purpose, but their physical muscle is very different. A home router is an all-in-one appliance. It combines a router, a switch, a firewall, and a wireless access point into one small plastic box. It is designed for simplicity and low cost, but it can only handle a small amount of traffic before it becomes overwhelmed and needs to be rebooted. An enterprise router, like a high-end Cisco or Juniper unit, is a dedicated, rack-mounted powerhouse. It often has no Wi-Fi at all. Instead, it is built for extreme reliability and throughput. It can handle millions of packets per second and run complex routing protocols, like OSPF or BGP, that allow it to automatically find new paths if a major fiber optic cable is cut. These routers are the steel beams that hold up the infrastructure of the global internet. Security, the first line of defense. From a cybersecurity perspective, the router is your front door. Because it sits between your private network and the public internet, it is the first thing a hacker will try to attack. A professional router uses access control lists, or ACLS. These are strict sets of rules that tell the router which types of traffic are allowed to enter or leave. For example, you might configure an ACL that allows web traffic, port 80, to enter your network, but completely blocks RDP, port 3389, to prevent hackers from trying to take over your servers from the outside. Furthermore, as we explored with VPNs, a router is often the endpoint for secure tunnels. It performs the heavy mathematical work of encrypting your data before sending it out into the untrusted world of the internet. Troubleshooting, the default gateway. If a user can talk to the printer next to them, but cannot reach Google, the problem is almost always the router. In networking terms, the router's internal IP address is known as the default gateway. When you look at a computer's network settings, the default gateway is the exit sign for data. If that IP address is typed incorrectly, or if the router has frozen, the data has no way to leave the building. As a technician, the first thing you will do is try to ping the default gateway. If the router responds, you know the local wire is good, and the problem is likely further out with the internet provider. By mastering the Layer 3 logic of the routing table and the protective power of access control lists, you will be prepared to manage the vital gateways that connect your organization to the rest of the world.